Okay, so I wanted to take this video and just kind of extend on to the previous lesson that we discussed, which was simplifying radicals, simplifying those square roots. I want to look at some problems that we have for homework and maybe just do this problem as well. Just to maybe sort of help you out. I think maybe only a couple examples from yesterday wasn't really enough, so I want to just make sure we sort of get the full idea of it all. So let's try this example first. I'll try to keep this video short, but also hopefully pretty well informed. So here I've got the square root of p to the 6 over q to the 10. Now when I have a fraction, it's helpful to first look at this fraction and see if I can reduce anything or cancel anything out. Now, because there's only the p's on top and there's only q's at the bottom, there is really nothing that cancels out here. So, and of course there's no numbers that I could potentially reduce either. So I can't really simplify that fraction any further. So now I'm going to start worrying about doing all the square root stuff. So with any fraction that has a square root, I'm going to separate these square roots individually, have one for the numerator and have one separate for the denominator. We can do that. Remember we talked about that yesterday in the previous video, that if you have a fraction you can split it up like this. Right? And I'll just consider this really to be like two problems in one. So let's simplify the square root of p to the 6. Now I said in yesterday's video that if you have an even number exponent, in this case I have an even number 6, all you do when you take the square root of that is just pretty much take half that exponent. So the square root of p to the 6 is really just p to the 3rd. Now here's the thing people get confused on. It's not the square root of p to the 3rd. It is not that. That's a no-brainer thing, okay? It is just a regular p to the 3rd. And just to finish this problem real quick, because q to the 10, that's also an even number exponent, we only have to take half that. And the square root of q to the 10 would be q to the 5th. Now, some people will probably understand why, and again, it's not the square root of q to the 5th, it's just a plain q to the 5th. Why is that the case? Well, just as a reminder to you that when you multiply variables and exponents together, all you do is essentially add their exponents. So the square root of p to the 6 is p to the 3rd because p to the 3rd times itself is p to the 6th. Because p to the 3rd times p to the 3rd, if you think about it, it's not p to the 9th. You don't actually multiply the exponents because what this really says, if you open it up, p to the 3rd is p times p times p. Right? That's 3 p's multiplied together. And of course you're multiplying, right? Bring that multiplication down. Another p to the 3rd, which is p times p times p. Which means altogether you're doing p times p times p times p times p times p, which essentially is p to the 6th. So these numbers are essentially counting how many p's you're multiplying. And so if you multiply 3 p's with 3 more p's, and you're multiplying together 6 p's. And that's going to be the case for any of these, any even number, any exponent. Q to the 10th is, like I said, q to the 5th times itself q to the 5th, because you multiply 5 q's together, and you multiply 5 more q's with it, and you're multiplying 10 q's all together, making q to the 10th. So again, the exponents are there just kind of counting how many that you're multiplying. So that's why essentially all you do is have to cut it in half. The square root of p to the 10th, that's the reason it's q to the 5th. Square root of p to the 6th, that's the reason it's p to the 3rd. Hopefully that helps a little bit. With the odd number exponents, it's essentially like the same thing. I know we didn't see one here, but let's pretend we had q to the 7th. What I typically said yesterday was take the biggest even number, which is q to the 6th, and then leave that odd number, that 7th q, separate. And the reason is because, again, this is still 7 q's. This is 6 q's multiplied together. And then that's 1 q multiplied to it. So it's still q to the 7th, technically. But we can separate them out. Right? And, of course, do the square root of q to the 6th. And then do the square root of q. Which, of course, we already know how to do this because it's an even number will just be a plain q to the 3rd. And I can't simplify this q at all, which is going to be stuck under the square root of q. All right, so that's why, in case you didn't already know how those variables works, there's a little bit of a refresher for you. But now let me jump into just one or two of the homework problems, just to sort of help you out a little bit, give you a little bit of aid. I can't erase that, can I? Well, let me erase all this first. All right, so one problem on our homework was, let's do like number 6. Number 6 is the square root of 28 f to the third, g to the 12th, and h to the 5th. The first thing, since everything in there is being multiplied together, by the way, this would not work if they were being plus or minus signs, but because everything is being multiplied together, we could separate all of them out. Because remember, the rule from yesterday was, if you have two things being multiplied in the same radical, you could separate them into their own radicals, right? That only really works if you're multiplying. It's not going to work if it was a plus b. So keep that in mind for the future. All right, but of course, in this example, we're multiplying everything, so of course this property will work, which means I'm going to separate all of these things out, create them to be individual sort of problems. So the square root of 28, separate that from the square root of f to the third, from the square root of g to the 12th, and the square root of h to the 5th. All right? Because of this property, I can do that. I can break them up into their own individual pieces. And then I'll treat this as basically 4 different problems. So the square root of 28, a reminder of what we're going to do here. When it comes to numbers, you're going to try to find any perfect square that's divisible into that value. So these are some perfect squares. Of course, there's plenty more. But I have to first decide, are any of these numbers divisible into 28? And if so, what's the biggest one? The biggest one is actually just 4. 4 is the biggest number that divides into 28. Well, yes, it's 4 and then 7, right? 4 times 7 makes 28. So we're looking for the pair of numbers that multiply to 28, but we want one of those numbers to be a perfect square, which is why, I've used these to sort of help me out. Alright, so square root of 28 is the same as square root of 4 times 7. Again, based on this property up here, I'm going to separate these out. The square root of 4 times the square root of 7. Of course, I do know the square root of 4. Square root of 4 is 2, so this is just going to become 2, whereas the square root of 7, I cannot simplify that anymore. There is no perfect square of 7. There is no perfect square divisible into 7. So it's kind of left in that radical. And there's the square root of 28 simplified. Now all these are the exponents again, so I go back to what we just talked about, f to the third power. I usually, again, would like to say, let's break this up where I find the biggest even number, which is obviously 2 before 3. The biggest even number before 3 is 2. And then you have 1 left over. And if you separate these out from each other, you do the f squared separately from the f. Well, the square root of s squared, because it's an even number, you just take half of it, remember. So that's just going to become a plain f. The square root of f, I cannot simplify that anymore, just like I could simplify the square root of 7, and it stays underneath the radical. So the square root of f to the third becomes f square root of f. Let's look at the g now. Since g is an even number, all I got to do is take half of it and I'll be done. So g to the 12th, the square root of that will be g to the 6th. There's really nothing to change there. Let me just bring it down. Okay, it's going to be part of my answer. And then h to the 5th. H to the 5th is an odd number, so again, let's break it up. We'll have the biggest even number, and then that 5th h, right? The biggest even number before 5 is 4. And we'll have, so h to the 4th, and then that 5th h off to the side. And then we'll split these up. And of course, because h to the 4th, that's an even number exponent, all I got to do is take half of that. The square root of h to the 4th is a plain h to the 2nd. Again, there's no square root. Once you've done the square root, you're done there. Square root of h, I cannot take that out of the square root. That gets left as a remainder, just like the square root of f previously and the square root of 7 previously. So I've done it. I pretty much solved it. This is my final answer. But I'm going to rearrange things, just order it so it looks a little bit neater. Anything that's not inside a radical, I'm going to write in the front, and then whatever's under the radical, I'll leave under the radical. So, for instance, I've got 2. Alphabetical order is usually helpful as well. 2 is outside of the radical. I have an f outside the radical. I've got a g to the 6th and an h to the 2nd. So g to the 6th, h to the 2nd. Outside the radical. So I'm going to just go ahead and write those first. And now what's inside the radical? And I'm going to put these all together since we are multiplying everything here. I have a 7 inside the radical, I have an f inside the radical, and I have an h as well. So this is really my final answer. 2f g to the 6 h squared, radical 7fh. There it is. And then just one more, just for good fun. Number 9, hopefully I can kind of squeeze it in here, is square root 6f g to the 7 over 27h squared. All right, now again, because this is a fraction, let's look at just the fraction part here and see if I can cancel anything out or reduce anything. Let's start by looking at those numbers. I have 6 over 27. Just look at the 6 over 27. Okay? Let me pull this off to the side for a second. Let me just do it right here. 6 over 27. Can I reduce that fraction? Well, I certainly can, because both of these numbers are divisible by 3. So if I divide both these by 3, I will have 2. 6 divided by 3 is 2, and 27 divided by 3 is 9. So this fraction will become 2 over 9. So let me just rewrite my problem here. All right, but instead of writing 6 over 27, I'm going to have 2 over 9. Now let's focus on the variables. The variables will only simplify if they can cancel out. I have, let's see, I have an f on the top, but there's no s in the denominator, so those won't cancel out. I have g to the 7th in the numerator, but I don't have any g's in the denominator, so there's nothing those will cancel out with. And of course I have h's in the denominator, however there are no h's in the numerator to cancel out with. So really I can't cancel any of those variables out. They're all going to be just sort of the same here. F g to the 7th h squared. But I've simplified the fraction. So in theory, it's going to make the problem a little bit easier, a little less complicated. And I realize I am going to need some space, so I will erase what I've done over here. Apologize. But you are watching a video, so if you really want to see it that badly, you can rewind it 4 or 5 seconds. There you go, okay? Alright. Alright, so I'm not going to erase the problem itself. Alright, anyway, so now, just like we saw previously, I can break these up. I can break the numerator up to just have the square root of 2f g to the 7th, and I can break this denominator up to just square root of 9h squared. So instead of it being under the same radical, I can have the numerator in its own radical, and the denominator in its own radical. But because, like I said, these are like their own, basically making 2 problems now, I can break these up even further, right? The square root of 2, the square root of f, and the square root of g to the 7th. Now, once you get really used to this, it's not really necessary what I'm doing here, but I'm going to do it just for those that are first learning this. This might help. This is kind of the way we've done it. And I'll break at the bottom as well. Square root of 9, and then the square root of h to the 2nd. So really, everything is inside its own square root, and that's simply because everything's either being multiplied or divided here. Again, this would not work if there was any plus signs. Keep that in mind. All right, so one thing at a time, the square root of 2. Well, I can't simplify the square root of 2. It's just going to be left as the square root of 2. It's not divisible by any other perfect squares like you see over here. 2 is not a perfect square itself, so I can't really change that. Square root of f, same thing. It's just a single f. I can't take the square root of that. It's going to be stuck the way that is. Now, g to the 7th, though, I can. Let me do that over here if I'm on the side. All right, the square root of g to the 7th. Well, since it's an odd number, again, let's break it up. Biggest even number, 4, 7 is 6, and then that 7 g is separate. You can split these up. And square root of g to the 6th is just a g to the 3rd, right? Just taking half of it. And the square root of g I can't do anything about. It's going to be left under that radical. So we're going to have g to the 3rd and square root of g. Over the square root of 9, I know square root of 9 is 3, right? That's just simplifies into 3. And the square root of h squared, again, that's another even number. That's just a plain old h. So here's pretty much my final answer, but let's write it a little nicer. Again, anything that's outside the radical, I like to write in the front, and then leave whatever under the radical last. So on the top, the only thing outside the radical is g to the 3rd. And everything else, the 2, the f, and the g, are still in the radical. So that's as simplified as the top will get. And then at the bottom, of course, you have 3H. I can't really do anything left. So there's my final answer again for number 9. I hope this video helped a little bit with your homework and explained things, I mean, to the best that I could. If you still have any questions on any of the other problems, please let me know. Come by Lion Time or doing tutoring. I'll certainly be willing to help you out. All right, I'll see you guys later. Bye-bye.